Okay, so in this video, we're going to take a look at integration by parts and try to derive the formula for integration by parts. The reason I'm actually making this video is because when I was in Calculus 2, we used to deal with a lot of formulas, and we weren't really told exactly where the formulas came from. And I'm sure a lot of you might have a similar experience. And what I like to do was try to rederive the formulas so that I could have a better understanding of them. So over here, what we're going to do is we're going to try to derive the integration by parts formula, and it's really simple. It only takes a few seconds, and the formula is actually a result of the product rule. When you derive the product of two functions, you can actually get the integration by parts formula. In fact, that's where it comes from. It comes from the product rule of derivatives. So we can start by considering two functions, right? V equals v of x and u equals u of x. Okay? And we're going to multiply these functions and take the derivative. Okay, so we can write d dx of v times u is equal to u times dv dx plus v times du dx. Okay, so at this point what we can do is just solve for u times dv dx, and if we do that we get u dv dx is equal to d of v times u dx minus v du dx. Okay. If I now multiply across by dx, I get u dv is equal to d of v times u minus v, let me rewrite this, minus v times du. Okay. Now all I have to do now is just integrate both sides of the equation, and we see that the integral of u dv is going to be equal to the integral of d of v times u minus the integral of v times du. The integral of dvu is just vu, v times u. So we find that u dv integrated is equal to v times u minus integral of v du, which is the integration by parts formula. Okay. There we go.